We're going to go over several examples of how to write the names of a mixture of ionic and covalent compounds. So the very first thing, of course, that you need to do is to identify the type of bond that the compound has. So let's look at the first example. We have K2SO3. One of the things that I noticed is that potassium is a metal. Remember that anytime you have a metal, it's going to be ionic compound. Also, SO3, sulfite, is also a polyatomic ion. So what I'm going to need to do is to use the rules for ionic compounds. So I'm going to name the cation first, so that's going to be potassium. And then I'm going to write the name of the polyatomic ion, sulfite. Notice that I did not use a Roman numeral because potassium is not a transition metal. Let's move on to the next one, Rb2s. One thing I noticed is that rubidium is an alkali metal. So because I have a metal, it's going to be ionic. When you have an ionic compound, we name the cation first, and then we put an IDE suffix on the second element, the anion. So this is going to be rubidium, no Roman numeral because rubidium is not a transition metal, and then sulfide. Notice that this is just regular old sulfur. It's not a polyatomic ion, so it's just going to be regular sulfur with an IDE suffix. We have, on the next example, CaF2. Notice how calcium is a metal. It's an alkaline earth metal. So because of that, I know it's going to be ionic. Then I'm going to name the cation, calcium, no Roman numeral because calcium is not a transition metal. We have fluorine, so we need to add an IDE suffix, fluoride. Number 15, SF6. Notice how that both of these elements are nonmetals. Anytime you have two nonmetals together, it's automatically going to be a covalent compound. With covalent compounds, I must use prefixes unless mono would be on the first element. It's okay to use mono on the second element, but not the first. So because sulfur has an understood subscript of 1 here, but I can't use mono on the first element, it's just going to be regular sulfur. Now I'm going to use the prefix for 6, which is hexa, so I'm going to have hexafluoride. Next we have ZNO. One of the things that I noticed is that, I meant to go back here, that was covalent. Zinc is a transition metal, and when I have transition metals I need to use a Roman numeral. When I use the Roman numerals here and I uncross my charges, one of the things that I notice is that oxygen is always a -2. So what happened to the 2 that is here? Well, it got reduced from a 2 down to a 1 in an empirical formula. So because this was an empirical formula, I'm going to have to work backwards to try to figure out the transition metals Roman numeral or charge. So to do that, if this subscript got reduced from a 2 down to a 1, then this subscript also got reduced by the same factor. So when I go to uncross that charge for zinc, zinc used to be a Roman numeral of 2 or a charge of 2. So I'm going to write zinc, Roman numeral 2, and then oxygen with an IDE suffix, oxide. The next one is a little similar. Notice how I have a transition metal, so I automatically know it's ionic, and that's the element silver. So when I go to figure out the Roman numeral of silver, there's nothing written here. So remember that you have to review that that is understood to be a subscript of 1. So silver is going to be a charge of 1. Let's make sure that chlorine is correct. It is. Chlorine's always a -1. So nothing weird going on there with empirical formulas. So we have silver, 1 chloride. On the next example, I'm noticing that I have sodium, which is an alkali metal. So because I have a metal, I automatically know it's ionic. NO2 is going to be a polyatomic ion as well. That's another indicator that it's ionic. So we're going to name the cation, sodium, no Roman numeral because sodium's not a transition metal. Then I need to name the polyatomic ion, which is nitrite. Number 19, Cu2CO3. All right, as we write this one, copper is a transition metal. CO3 is a polyatomic ion, so both of those indicate that it is ionic. Now, one thing that's a little tricky when you go to write the Roman numeral for copper, a lot of people are tempted to look at this 3 here and think that that's the Roman numeral or charge for copper, but that's not the case. The formula for carbonate is CO3. So because of that, we have to understand that there is a subscript of 1 on the outside here. So when I uncross the charge of copper was a 1. Let's go ahead and make sure that the charge of the polyatomic ion, carbonate, is correct. So it says that it's a 2, and so if we go to uncross it, that is correct. So we don't have any empirical formulas going on here. And so our final answer is going to be copper 1 carbonate. And you are required to put the Roman numeral even if that Roman numeral is a 1. It's not understood. Let's go to the next example, AlF3. Aluminum is a metal, so it's going to be ionic. Lots of students, for whatever reason, think that aluminum is a transition metal. It is not. Look at its location on the periodic table. It is not in the D sublevel of the periodic table. It's not tin or lead, so no Roman numeral. So you simply need to name the cation, aluminum, and name the anion with an IDE suffix, aluminum fluoride. On the next example, I have nitrogen and oxygen. Those are both nonmetals. So whenever I have nonmetals, I know that it's going to be covalent. So I'm going to use prefixes, except remember you can't use mono on the first element, so this is going to be nitrogen. But it is okay to use mono on the second element. So it's going to be nitrogen monoxide. Remember, you can't put 2 O's together, so it's not going to be monooxide. All right, next we have a transition metal, Ti, titanium. So because this is a transition metal, I automatically know it's going to be ionic. I'm going to uncross the charges, so this 2 comes over here to titanium. The 3, let's double check, that is the correct charge for phosphorus, so no empirical formulas going on. So I'm going to write titanium. And then we're going to write the Roman numeral of 2, because that was the charge of titanium. Then we're going to write phosphorus, but with an IDE suffix, so that's going to be phosphide. All right, we have PCl5. Both of these elements are nonmetals. Whenever I have nonmetals together, it's going to be covalent. And so I'm going to use prefixes except for mono on the first element. So it's going to be phosphorus. All right, the second element is going to have a prefix of 5 for penta. And now I'm going to put the second element with an IDE suffix, so chloride. Remember, there are no charges, no uncrossing, very straightforward with just the prefixes. All right, next, notice that nitrogen, hydrogen, phosphorus, and oxygen are all nonmetals, but it is not covalent. One of the things that you have to recognize is that you actually have 2 polyatomic ions here. So when we name the ionic compound, we're going to need to look up the names of those polyatomic ions. So the first polyatomic ion is ammonium. The reason it's listed first is because it's a cation. Then we have PO4. The name of that polyatomic ion is phosphate. So it's just 2 polyatomic ions together, and you just have to list them. Last example is a little tricky. We have NiSO4. All right, nickel is a transition metal, so I automatically know it's ionic, but one of the things that is unique about this example is we got to check out sulfate, the polyatomic ion. Sulfate is always a -2. So when you look at that, notice that there is no 2 there. That means it must have gotten reduced. This is an example of an empirical formula situation where you have to figure out that Roman numeral by working backwards from before it was reduced. So if this got reduced from a factor of 2 down to 1, then this one must have also gotten reduced from a factor of 2 down to 1, because there's also a subscript of 1 understood to be here. So that means that this must have been a subscript of 2, and so if I uncross the charges, that means that nickel must have been a 2. Please don't be confused by the fact that there's a 4 on the outside here. That 4 is part of the identity of sulfate. The SO4 will always be sulfate. So what we're going to do is we're going to write nickel, Roman numeral 2, sulfate.